We're going to talk about systems of equations. Not a difficult idea, but it's pulling together a few items that we've already learned. So if I had an equation, and I'm going to write it in slope-intercept form, say y equals 3x plus 2. I'm sorry, say plus 1. And we have this equation, right? It's a linear equation. That's fine. If I had another linear equation, say negative 2x minus 5, and I told you that these two were related somehow, we would say that these two together are a system of equations. It's called a system, saying that there's more than one. It could be 2, 3, 4, 4, 5, 6, 7, whatever number of equations. We're only going to focus on 2 in this class for the most part. There might be an extension where I'll use 3, but basically just 2. All right, and a system of equations can be solved. It can be solved. You can come up with a solution to a system of equations. Where is it solved? The solution to a system of equations is where they both meet. The solution is where they both meet. And by that, I mean where they are both equal. So let me write that. Where they are both equal. All right. So if I were to, I'm just making up an example here. If I had a graph and I drew a line, that was the equation of one line, and I had another line and they intersected, then that point right there where they actually meet, this point right here, that is the solution to that system. If I told you that that coordinate, those coordinates were say 1, 2, then the solution to this system of equations would be 1, 2. It's where they are both equal. It is a point. Okay, so if I'm talking about solutions in a system, I can have, I'll just say types really quickly of solutions. It's not the best way of calling this thing, but types of solutions. I can have 3 different kind of scenarios, right? If I'm looking at this, I could have the scenario where I just showed you one. You have a graph and you have another graph and they meet right here. In that case, we have one solution. It only meets one time. If I had a graph that went like this, and much like we talked about in the last unit, they were parallel, then there are no solutions because they don't intersect, they don't meet. I could have a line that does this, and I could have another line, and I'm trying to make it land right on top of it. That's my intent. So 2 lines that are basically the same. They may be written in a different format, but they are the same line. If I have that, then I have infinitely many solutions. Infinitely many. And I have infinitely many solutions because, again, a solution is where they are the same. Well, if they're always the same, then there are infinitely many solutions. All right. You go in Alex, you'll see that they'll ask you some questions like that. This thing right here would be, since it's parallel, it has no solution. This thing right here, since it's 2 of them, see there are 2 lines, but they all land on the same spot, that one has infinitely many solutions. And this one only intersects once, so it only has one solution. And I can tell you that that solution is 1, 3. All right. So that's good to know. That's good stuff so far. We may also need to, we can use that information to see whether or not something is a solution. If it's a solution, then it has to satisfy both of those items, right? So if I had, and I'm not going to use that example, I'm going to use a faster one. If I said, I don't know, y equals 2, that's a horizontal line, and then y equals 2x plus 1. If I wanted to see if 1, 3 was a solution, I would plug it in here. If I plug it in here and it's true, and I plug it in here and it's true, then it's a solution.